Hello and welcome to another segment on differential equations. Today we shall be beginning this segment by the definition of a general and particular solution. Later we are going to find the solution of a differential equation by the method of separation of variables, and finally we shall conclude this lecture by discussing a numerical problem that would be based on the method of separation of variables. A differential equation has two solutions, general solution and particular solution. So starting with the general solution, which gives a solution of a differential equation with arbitrary constants equal in number to the order of differential equation. A particular solution is obtained by giving a particular value to the arbitrary constant in a general solution. Next we are going to discuss differential equations in which the variables are separable. The equations that can be expressed such that the coefficient of dx is only a function of x and the coefficient of dy is the only function of y. These type of differential equations are solved by the method of separation of variables. Thus, the general form of such an equation is given as f dx plus phi y dy equal to 0, where fx denotes the function of x and phi y denotes the function of y. Now in order to solve this, we may write this equation as fx plus phi y dy by dx equal to 0. Now we are going to integrate this equation with respect to x, and we get the equation in the integral form as integral of fx dx plus integral of phi y dy by dx equal to c, where c is a constant of integration. Or we may write this equation as integral of f x dx plus integral of phi y dy equal to c. This is the solution to equation number 1. Thus, the solution of equation number 1 is obtained by adding the integrals of fx and phi y with respect to x and y respectively and equating their sum to a constant. Next, we are going to discuss the steps that are involved in finding the solution to a differential equation in which the variables are separable. The first step that is to be done is to separate the variables, that is x and y terms, then integrating both the sides, and finally we are going to add a constant to the integrated terms. Finally, we are going to discuss a problem that is based on the previously discussed steps for a differential equation where the variables are separable. Now here we have an equation which is y bracket 1 plus x bracket close dx plus x bracket 1 plus y bracket close dy equal to 0. Now since in this equation the variables are separable, therefore applying the steps that we have previously discussed, we can write the equation as bringing out the y terms onto the one side and x to the other. We have y 1 plus x dx equal to minus x 1 plus y dy. Now rearranging the x and y terms, we have 1 plus x by x dx equal to minus 1 plus y by y dy. Now next step is to integrate these terms. So integrating these terms, we have 1 by x plus 1 dx equal to minus 1 by y plus 1 dy. This gives us the value log x plus x plus log y plus y equal to c. Or we may rewrite this as log xy plus x plus y equal to c, where c is a constant. So by the use of variable separable methods and the steps that we have discussed, we have found the solution to this differential equation as log x y plus x plus y equal to c. Next we are going to discuss equations that are reducible to variable separable. If the given differential equation is of the form dy by dx is a function of ax plus by plus c, then we are going to put v equal to ax plus by plus c, and it will be reducible to variable separable. Next we are going to discuss a differential equation which is of the form that is reducible to variable separable. Here we need to solve a differential equation which is of the form dy by dx equal to 2x plus 3y minus 4 whole power 2. Now this is of the same form as we have discussed earlier. As discussed, first we are going to put 2x plus 3y minus 4 equal to v. Now this equation is being labeled as, let's say, 1. Now we are going to differentiate this equation with respect to x. Thus we have dv by dx is equal to 2 plus 3 dy by dx. This implies that dy by dx is equal to 1 by 3 bracket dv by dx minus 2, which is being obtained by rearranging the terms of this equation. Now substituting these values in the given differential equation, that is equation number A, we have 1 by 3 dv by dx minus 2 is equal to v square. This further gives us dv by dx is equal to 3v square plus 2. This implies that dx is equal to 1 divided by 3v square plus 2 dv, which is equal to 1 by 3 dv by v square plus 2 by 3. Now on integrating both the sides of this equation, which is being labeled as equation number 2, we have x equal to 1 by 3 integral of dv by v square plus root of 2 by 3 whole square plus c. This is equal to 1 by 3 1 divided by 2 by 3 square root 10 inverse v divided by root of 2 by 3 plus c. This gives us the value of this differential equation, which is being reduced to variable separable method by substituting 2x plus 3y minus 4 equal to v. Now here c is an arbitrary constant. With this we conclude this lecture on differential equations.